Hello everyone, my name is Joe Scorsone, channel is called Scorsone Enterprises, and today we're going to be doing some HTTP actor stuff. In Zig, we're going to be using my actor model in Zig's standard library to make an HTTP server as a struct that lives on our actor model. So that way, we can have a server handling all of our requests on one area, and then actors, different structs that we make in another area, right? So we're only going to be making the server right now, but yeah, I thought that this would be a cool project. Eventually, I think I want to make it into an actual web framework. I'm kind of in two minds between it's so stupidly over-engineered, why would you do it? And it's so stupidly over-engineered that I should totally do it. So, who knows? But yeah, that's what we're gonna be doing today in Zig. So, before we hop into it, check out my Twitter. Everything on here. I made the first community for Delta Gamma Psi, the community I want to start, just a free one. Quant Frat is what we're really calling it. I made the first community on X, so go ahead and join that. It's totally free. I'm still making the Discord. And check out the indicators I made in collaboration with LuxAlgo. Use code JUL30 for 30% off. Today on Spaces, if you followed me on X and got on the Spaces when I was on, you would have called Google for 30% with me. And a few days ago, you would have caught RTX for 100%. You would have stopped out for GE minus like 15%, and you would have closed your LHX, and you would know about Palantir. I'll go along with the levels, looking to break through this level, and then clear skies ahead. So you can know when all this is going on for the first time if you follow my X and subscribe to the algos. So that's that. None of that's financial advice, but right. So I tried to code this. Let me make my face a little bigger. I tried to code this along with you guys, but the video ended up being 35 minutes. So we're not going to do that. I'm going to go through and I'm going to talk about everything because it's just 160 lines of code. But I like to yap, basically. So, right. So I already have Inklist, my actor model, in my project. I just get cloned it, put it in here, and then just adjusted my root in there. So just lib Inklist. There we go. Right. So now in my glorious main file, I can just import everything I need right there. These are the other imports that we need. And we're actually going to start backwards. We're going to go into the main, and I'm going to show you guys how we're doing everything. And then we're going to go through and actually talk about how it's all working with the actor model and stuff like that. So the first thing we're doing is making our engine, and then we're making our server by spawning the server struct that we're going to make. This returns a U64, or it might. We have to try, right? This should return a U64. Then we need to make context. That way, when we make function payloads, functions for the actor model, the actual engine to call, then we can know who sent it, what the payload is, with all of the functions from our context. Same thing to do something else, right? This is to handle start, this is to handle initialization. Everything else is the same. And then we can wait for our actors to keep the event loop for our requests going over and over and over again. And then we just actually have to stow that time that sleep to just sync just everything at one point, right? So yeah, now let's actually go through and talk about this. Every struct that you want to make an actor needs three methods. It needs an initialize, a deinitialize, and a receive. And they all have to have these signatures. Now, let's go over how ours actually works. So this just needs an allocator, an address, and a server. But we're going to have these optional at first, because this will all be done from the messages that we send to our actor engine. So we're just going to initialize everything, but we're just going to set these to null at first. And then deinitializing just checks and then DNS, right? Now this is just to spawn the actor. This is to get that U64 we were talking about earlier. This is what gets called. And then the actor engine stores this stuff. Now, when we want to be able to call these things, this gets done from context. So that way, everything can be nice and generic, right? So now let's keep going here. To initialize our server, So that way we can keep all of our function signatures correct for the actor model and keep everything as generic as it can be. We're going to pass in our port here. Then this is still in our actor server, so we have self. We're going to set our we're going to initialize our address here. We're going to parse this and then this returns a address or an IPv4 error or a address. And then we're going to store that in our struct self.address. We're going to make sure it's there. If it is, then our server is listening on it because this returns a server. It's a net.server, right? So now, this is really interesting because now we could wrap this in context and not actually have to call it ourselves. Our actor model handles this via messages. Basically, all through this receive function. Ignore this increment counter. That's from the example main I put on the GitHub. Right. But we don't have any custom messages in here yet, so we could just kind of do nothing. But to call this call function, f.context, for a handler payloads, call the handler's function. So now when we actually make a function payload, right, call function, right here, we have this signature that we need to keep constant. And then this is what gets called. So up here in our receive again, f.call function, and then we're just putting our parameters in. So we need context and something. But that is what it is. We need two things. We don't know what it is yet. This is how we're keeping things generic. So that's the same concept, but to start a server. We happen to not need any, right, we're talking about initializing the server. But now to start the server, we don't need any other parameters. This is just the event loop. Just make sure that we have a server. While true, accept connections, store our actual connection in a variable, so that way we can actually access it. We can actually get an HTTP server from the connection and then receive stuff from that connection, right? Receive head. These are the requests. Well, the request is what the header byte the header bytes reference the read buffer that the server was initialized and remain alive until the next call to receive head. And this returns the request. So that's how we actually get it, and then we can actually handle our request. We're just echoing here, so we're going to say request.respond, and then just hello HTTP, right? And we're also printing that out to the console. So this will make more sense too when we actually look at the context. Context, we need an init function just because it's Zig. We just need init. And then we need a dinit and a clone. This is just so that way, again, to keep everything generic, if we ever need to clone the message or anything like that, just make sure that we have everything. Now this is actually what we're going to be using in our code, right? We're going to handle our initializing. We're going to get our self and our server from these two parameters. The context, what we're doing. The context is this struct, myself. This is what our context represents. And then the actor is whatever type actor server, right? This is the context, this is the server. And so now we can do stuff on our server and we can access the port and everything like that. So we can initialize the server on the port and then it's initialized. That's it. We're just editing the server, right? So this context function calls this. Same concept here. We need to maintain this signature. So we're just getting rid of the context there. Doesn't matter. And then we're saying the server, same idea, getting our actor that we have here because it's a pointer to something. So we're casting it to get all of our types out because we know what type we want. That's the thing. We know what type it is. We just have to make sure that the actor engine doesn't care. And then we're getting that, and then we can start our server. And then we can wait for it indefinitely for that while loop. So now this is how, that's the whole flow of it. The whole reason I wanted to make this was just so I have a consistent way to write my Zig. Right? It's a little chewy at first, it really is, but now when you think to yourself, like, okay, like I have something that's going to do something, right? This isn't going to be efficient if you just have to do something simple. Then you're just adding a lot of overhead for no reason. But if you need to do a lot of things, and you need to do things in the background, if it just gets complicated, right, and you actually want a way to handle all this complexity, you want to be able to do things concurrently with the thread pool and the actor model, or the actor engine, right, then you can think to yourself, okay, I'm going to make my thing, and now I just need to make contexts to call the things in my thing. That's how I thought about it. It's really just a method for consistency and concurrency at the same time. Because even if you notice here, I'm making a message, I'm not deinitializing it. The actor model takes care of that. The engine takes care of it. Even I'm not even deinitializing this actor. The engine takes care of it. This handles everything for us. All of our memory management, all of our concurrent stuff, and it's all in one struct. We just have to write it in a way that it maintains being generic, being agnostic to what the thing actually is. It's just getting stuff, and it's doing stuff with it. So let's run this, just make sure that we're all good. So zig both run. Then if we open up another terminal with it, right, we can say listening on port, whatever, whatever. And then if we just curl, hello HTTP, handling request for whatever. So now, of course, this is like, it's not actually doing something complicated, so of course it's fast. But yeah, that's the whole point of it, is to be able to because it's not necessarily that the server would handle connections concurrently because of the actor model. It's that the program can be doing a bunch of things concurrently with the actor model. The actor model is handling that the server is alive and doing stuff, and it's handling that actor B is alive and doing stuff, and actor C is alive and doing stuff. If you're streaming anything from another source, then you could just have that going on in the background. Your actor models, your actor engine is handling all of it. That is the thought behind it. And here we're at 12 minutes to explain how we're making a HTTP server live as an actor, which is way better than 35 in my opinion. So if you guys watched to the end of the video, thank you. You're a legend. Check out all this code is in the description. All the stuff I talked about in the beginning is in the description. I'm going to commit this comment. And yeah, I'll catch you guys in the next one. Have a great one. Peace.